The first time I saw a massive animal rising from the depths, I didn't feel fear. I felt a strange suspension of time, like my brain had briefly forgotten what was even possible. It was too big, too quiet, too ancient. A living shadow that felt like it belonged to another planet. And in that moment, one question got stuck in my mind. How can something so colossal exist in an environment with almost no light, almost no heat, and almost no food? Today, you're going to get that answer in full. We're going to explore why the most resource-poor ecosystem on the planet is home to absurdly large creatures, what science has learned about this in recent years, and what it all means for the future of our oceans. Get ready, because understanding deep-sea gigantism is like discovering a completely different set of rules than the ones we know on the surface. Most people imagine the deep ocean as a silent, lifeless desert, but recent scientific expeditions show the exact opposite. There is life down there in abundance. It just operates by entirely different rules. Some of those rules feel counterintuitive. Others seem almost paradoxical. But together, they form the most elegant explanation for a phenomenon that, for centuries, was treated as myth: the rise of giants in the most hostile place on Earth. First, we need to dismantle a myth almost everyone believes: the pressure myth. People often say nothing large can survive in the deep because the pressure would crush it. But the truth is, marine animals are mostly made of water, and they are surrounded by water. The pressure balances out inside and outside the body, just like a water-filled balloon submerged in a tank. It doesn't get crushed, it adapts. So, pressure isn't the real barrier. The real challenge is what comes with it: absolute darkness, extreme cold, and an almost total lack of food. Think about what it means to live without sunlight. Below about 3,300 feet, the sun disappears completely. No shadows, no colors, no day or night. Just endless darkness. Without light, there's no photosynthesis. Without photosynthesis, there are no plants or algae. And without them, the base of traditional food chains collapses. Down there, almost everything depends on scraps falling from above, microscopic particles drifting slowly downward, bioluminescent organisms barely hanging on, and extremely rare events like a whale carcass sinking to the seafloor. With so little food available, it seems impossible that giant animals could exist. But here's the first major paradox. In environments of extreme scarcity, being large is actually an advantage. This is due to a biological principle called metabolic efficiency. Larger bodies lose proportionally less energy, store more reserves, retain heat longer, and can survive for long periods without eating. The logic is simple. The bigger the organism, the slower it burns through its resources. Think of your phone at 1% battery. Now imagine replacing that battery with a much larger one that drains more slowly. That's how large deep-sea animals function. They conserve every bit of energy, which is essential when a meal might not appear for months. Cold takes this to another level. Deep ocean water sits near freezing temperatures. For humans, that would be fatal within minutes. But for deep-sea animals, the cold is a massive advantage. It drastically slows chemical reactions in the body, reduces metabolism, lowers energy consumption, and increases the amount of oxygen dissolved in the water. Yes, cold water holds more oxygen. The colder the water, the more oxygen it retains, which is critical for supporting large bodies that operate slowly over long periods of time. During an Arctic expedition, I once put my hand into the water for just a few seconds and felt immediate numbness, like my body was shutting that area down. Now imagine evolving in that environment for generation after generation, until the cold itself becomes a tool. Deep-sea animals turned cold into a survival strategy, a way to live in slow motion and stretch every calorie across decades. Some species age so slowly that they keep growing for centuries. That's the case with certain giant sponges, which can reach the size of small cars and live motionless like silent mountains in the dark. And then there's the Greenland shark, maybe the most astonishing example of all. It grows just a few millimeters per year. Some living individuals today may have been born before the invention of the telescope, but deep-sea gigantism isn't explained by cold or scarcity alone. There's another crucial factor: isolation. The deep ocean functions like the largest island on Earth. On isolated islands, small animals often grow larger because predators are scarce. Large animals tend to shrink because food is limited. In the deep sea, both processes happen at the same time. Extreme scarcity favors large bodies that conserve energy, and the lack of large predators allows those bodies to grow without constant threat. Imagine descending thousands of feet inside a submersible. With every meter, colors vanish, sounds change, light fades. The environment starts to feel ancient, almost frozen in time. Then down there, you encounter creatures that look more like sculptures than animals. Long arms like cables, gelatinous bodies glowing with their own light, enormous eyes adapted to capture the faintest trace of illumination. It's a world so isolated that each species followed its own evolutionary path, developing solutions found nowhere else on Earth. One of the creatures that shocked me the most in person was the giant isopod. I expected something small, maybe palm-sized. Instead, it looked like a cross between a pill bug and an armored tank, scaled up by thousands of %. It moved slowly across the seafloor, so slowly it felt almost paused. It was an animal designed to survive where nothing goes to waste, perfectly shaped by scarcity. The same goes for the bigfin squid. Sightings are so rare that every new image becomes global news. Its arms extend downward in straight lines, like rigid wires, reaching several feet in length. It moves so slowly that it sometimes appears motionless, as if it's quietly observing the ocean around it. And then there are the giant siphonophores, possibly the strangest organisms on Earth. They can exceed 150 feet in length, but they aren't a single animal. They're entire colonies functioning as one. Each part has a specific role, like organs in a larger body. It's literally a colony with collective functionality. Now we reach the most delicate part of this story. Deep-sea gigantism is under threat. And of all the challenges these creatures have survived, natural climate shifts, ice ages, tectonic changes, the current one is the fastest and most intense. The ocean is warming. As it does, oxygen levels drop. Deep waters are changing chemically, and invasive species are moving into regions they never could before. King crabs, for example, once unable to survive in extreme cold, are now advancing into deep regions and preying on animals that evolved for centuries without defenses against them. It's like introducing a modern predator into a prehistoric ecosystem. The result could be catastrophic. Creatures that take centuries to grow could vanish within decades. The deep sea isn't resilient. It's fragile. It depends on stable conditions maintained over millions of years, and those conditions are now shifting right in front of us. Still, even in this troubling scenario, there's something deeply inspiring about deep-sea gigantism. It shows how life finds astonishing strategies to survive. It teaches us that slowness can be strength, that isolation can lead to perfection, and that extreme environments can give rise to creatures that challenge everything we think we know about evolution. Deep-sea gigantism isn't nature exaggerating. It's nature responding with elegance. It's life saying, even here, even like this, I exist. Now I want to know, which of these giant creatures impressed you the most? Leave a comment below, I'll be reading them all. And if you want to keep exploring this hidden world, subscribe. In the next episode, we'll analyze the most mysterious phenomena ever filmed in the deep ocean, real events captured on camera that science still can't fully explain. What exists in the depths is still far from understood, and we're only just beginning our descent.